Welcome to G Fun Facts Online. Today, we are not talking about a star or a planet or even a galaxy. We are talking about an event. An event so colossal that it fundamentally challenges our understanding of scale in the universe. Imagine for a moment the Milky Way galaxy. It is our home, a spiraling island of stars roughly 100,000 light years across. It takes light, the fastest thing in the universe, 100,000 years just to cross it. Now, imagine lining up 140 Milky Way galaxies, side by side, in a straight line. That unimaginable distance is the length of a single structure recently discovered by astronomers. It is a pair of bipolar jets, blasts of high-energy plasma, erupting from a supermassive black hole. They call it Porphyrion. Named after the king of the giants in Greek mythology who waged war against the Olympian gods, this celestial titan stretches 23 million light-years from end to end. It is the largest structure of galactic origin ever identified in the history of astronomy. Its discovery is not just a new record, it is a rewriting of the textbooks on how black holes interact with the cosmic web and the vast, empty voids of the universe. To understand Porphyrion, we first have to understand how we found it, because you cannot see this object with your eyes or even with a traditional optical telescope. The visible light universe, the stars and galaxies we see in pretty Hubble pictures, is only a tiny fraction of what is out there. To find a monster of this magnitude, scientists had to look at the radio sky. They used the low-frequency array, or LOFAR. This isn't your typical telescope made of giant dishes pointing up. LOFAR is a vast network of tens of thousands of radio antennas spread across Europe, centered in the Netherlands. It acts like a giant singular eye that scans the low-frequency radio waves of the cosmos. These waves reveal the faint, invisible whispers of ancient plasma that optical telescopes simply miss. An international team, led by Martine Oe from Caltech, was conducting a massive survey of the northern sky. Interestingly, they weren't explicitly hunting for a single giant like Porphyrion. They were looking for the cosmic web, the tenuous filaments of matter that connect galaxies together like a spider web. They used machine learning algorithms to sift through mountains of radio data, trying to identify patterns. What they found was a hidden population of giant radio galaxies. The algorithm flagged thousands of them, but one stood out, a faint, ghostly line cutting across the radio images. It was so large that at first glance, it looked like a glitch in the data. But it wasn't a glitch. It was a single, coherent object of terrifying power. Let's break down the anatomy of this Leviathan. Porphyrion is located about 7.5 billion light-years away from Earth. This is crucial context. Because light takes time to travel, we are seeing Porphyrion as it existed 7.5 billion years ago. That is less than half the current age of the universe. We are looking back into a time when the universe was denser, more chaotic, and undergoing rapid growth. At the center of this structure is a host galaxy, roughly 10 times more massive than our own Milky Way, and deep inside that galaxy sits the engine, a supermassive black hole. As matter falls toward this gravitational abyss, not all of it falls in. Through complex interactions involving twisting magnetic fields and extreme gravity, a fraction of that infalling matter is diverted. It gets blasted outward from the black hole's poles at near light speeds. These are the jets. Now, jets are common. We see them in many active galaxies. Usually, they sizzle out after a few thousand or maybe a million light years. The intergalactic medium usually disperses them, or the fuel source runs out. But Porphyrion is different. For reasons that astronomers are still debating, this specific black hole managed to keep its foot on the gas for approximately 1 billion years. Think about that stability. For a billion years, this engine spewed a continuous, stable stream of high-energy plasma. These jets punched through the host galaxy, exited the galactic halo, and pierced deep into the intergalactic void. They remained tightly focused, like a laser beam, over a distance that is cosmologically absurd. Before this discovery, the largest known jet system was Alcadius, which spanned about 16 million light-years. Porphyrion obliterates that record at 23 million light-years. To put it another way, the distance between us and the Andromeda Galaxy is about 2.5 million light-years. Porphyrion is 10 times longer than the gap between our two major galaxies. But the size is only half the story. The physics of Porphyrion is what really keeps astronomers awake at night. We typically classify supermassive black holes into two modes. First, you have the jet mode. These are the efficient eaters. They sip on fuel slowly and typically produce jets. Second, you have the radiative mode. These are the gluttons. They devour material frantically and shine brightly as quasars. Standard astrophysical models suggested that the chaotic, violent environment of a radiative mode black hole would destabilize any jets. Essentially, if the black hole is eating too fast and blasting out too much radiation, it should be able to maintain a neat straight jet for very long. But when the team analyzed Porphyrion's host galaxy using the WM Keck Observatory in Hawaii and the giant Mitra Wave Radio Telescope in India, they found a shocker. Porphyrion emerged from a radiative mode black hole. This disrupts a long-held consensus. It proves that a violently feeding black hole, one that is blasting out energy in all directions, can still maintain the discipline to launch a stable, cohesive jet that endures for 1 billion years. It suggests our understanding of black hole accretion disks and magnetic field alignment is incomplete. We are missing a piece of the puzzle regarding how these engines work. Now, let's zoom out. Why does this matter to the universe at large? Why should we care about a giant jet 7 billion light-years away? The answer lies in the architecture of the cosmos. We live in a universe structured like a sponge. Galaxies are not scattered randomly. They are strung along filaments of dark matter and gas, known as the cosmic web. Between these filaments lie the cosmic voids, vast bubbles of nothingness. Porphyrion is so massive that it actually reaches beyond the cosmic web. Its jets are injecting heat, magnetic fields, and heavy elements deep into the cosmic voids. This is a form of action at a distance that cosmologists hadn't fully accounted for. If a single black hole can heat up and magnetize a chunk of the universe 23 million light-years away, it means black holes are not just local gardeners pruning their own galaxies. They are the landscapers of the entire cosmos. Consider magnetism. The origin of magnetism in the void of space is a mystery. How do magnetic fields get out there? Porphyrion suggests that giant jets act as mechanisms to spread magnetic fields throughout the universe, seeding the intergalactic medium with the forces necessary for future structure formation. Or consider star formation. By dumping energy into the voids, these jets might heat the gas that would otherwise cool and fall into galaxies to form stars. Porphyrion could be responsible for stifling the birth of galaxies billions of light-years away from its source. It is an agent of cosmic feedback on a scale we previously thought impossible. Perhaps the most exciting realization is that Porphyrion is likely not alone. Martin Oy noted that we are likely seeing just the tip of the iceberg. The LOFAR survey found over 10,000 giant radio galaxies, though none as large as Porphyrion yet. However, remember that we are looking 7.5 billion years into the past. As the universe expands, the cosmic web stretches. In the early universe, filaments were closer together. Porphyrion shows us that, in those early epochs, black hole jets could bridge the gaps between filaments, creating a connected network of energy transfer that shaped the evolution of the modern universe. With the upcoming Square Kilometer Array, a new radio telescope project that will be far more sensitive than LOFAR, astronomers expect to find hundreds more of these supergiants. We are entering a new golden age of understanding the dark, violent, and invisible forces that sculpt our reality. Porphyrion stands as a testament to the power of nature, a single point of infinite density, generating a structure that dwarfs galaxies, conquers the void, and challenges the human mind to comprehend the true scale of the infinite. It is a 23 million light-year scar across the face of the deep past, reminding us that in space, even the nothingness is not safe from the reach of a black hole. Thanks for listening to this deep dive on G Fun Facts Online. If you enjoyed this journey into the radio sky, stay tuned for our next episode.